Hello viewers, welcome to this video. In this video, you are going to learn how to schedule a set of processes having its own priority using priority scheduling algorithm in operating system.
So next let me explain you about the priority scheduling. The the term priority itself means that some priority will be associated with every process. Okay. So the priority will be defined by an integer number. So a priority number will be associated with each process, which is so here the priority number will be an integer. Some systems makes use of lower numbers to represent the low priority, whereas some other operating system will make use of lower numbers to represent high priority. Okay. So it is up to the operating system to fix the priority. So now here let us assume that lower number represents high priority. So here, as far as priority is concerned, the CPU will be allocated to the process which has the highest priority. So when here preemption will occur in which where, say for example, now consider that process is getting executed. So in the meanwhile another process is entering the ready queue whose priority is higher, okay, than the currently running process. So in this situation, the current CPU will be preempted or released from the currently running process, and then it will be allocated to the process which has entered the ready queue because its priority is higher than the currently running process. Okay, so this in this case preemption will occur. If it is non-preemptive, then the whatever the higher priority may be, the process which enters into the ready queue, it doesn't matter. The CPU completes the execution of the currently running process and then looks into the ready queue for any process which is with highest priority. Sometimes more than one process will have the same priority. Okay, in that case what happens is that FCFS procedure will be followed between the process having same priority. Okay, that is the process which has arrived first will be given the priority first and then it will be executed. Okay. So we have already learned SDF algorithm, shortest job first. So SDF is one class of priority scheduling where the priority depends on the CPU burst time. Okay. So priority is not explicitly assigned, but it is based on the CPU burst time because the process which has the least amount of CPU burst time will be executed first. Okay. So that's why SDF is considered as a class of priority scheduling. So here priority may be assigned internally or externally. Internally means that the operating system itself will assign the priority based on the type of the process. Okay, if it is an interactive application, then for that kind of process more priority, highest priority will be assigned. If it is a background process, then some medium or low priority will be assigned. Okay, it is based on the operating system. Yes. In the other way, that is priority may be assigned externally by by the person who submits the job to the computer system or to the server. Okay, so based on the emergency of the application. Okay. So based on the type of the user, okay, so based on these criteria, this priority may be assigned. So the one problem what occurs here is the starvation. Starvation means that sometimes what happens is that the high priority process will be executing. Always high priority process will be executing, so that CPU will be locked by that particular high priority process. So in this case the low priority process will be waiting for a long time to get its turn for the CPU. So this particular situation is called as starvation. So this will cause a situation where low priority process will never get its CPU turn, so that it won't be executed. A solution for this is aging. Aging is a procedure where the priority of the process will be increased. So the priority of the process will be increased one at a time. So if, say for example, if priority of process 6, then it will be increased to 5. That is, here increase in the sense you will be assigning low priority number. Sorry. So let me explain you with some example. So this consider this set of process P1 to P5, whose burst time is given and priority is also given. So process P1 has priority 3, P2 1, P3 with priority 4, P4 with priority 5 and P5 with priority 2. So if you look into this process, P2 has the highest priority. Next to that you have P5. Then after P5, P1 has the highest priority, then P3 and then P4. Okay. Now let me explain you about the execution order of this process. So as far as the priority is concerned, P2 starts first. Okay. So the burst time of P2 is 1 milliseconds. So it completes first. Then comes the process P5. Okay. So whose burst time is 5. So 1 plus 5 is 6 milliseconds. So the completion time of P5 is 6 milliseconds. Next to P5, P1 has the highest priority, whose CPU burst time is 10 milliseconds. So 10 plus 6, 16 milliseconds. So the completion time of P1 is 16 milliseconds. Then after P1, P3 gets the turn of CPU. So its burst time is 2 milliseconds. So 16 plus 2, 18 milliseconds. Finally, P4 has the lowest priority, whose burst time is 1 milliseconds. So it executes for 1 millisecond after 18 milliseconds. So the completion time is 19 milliseconds. Okay. So this is the order by which the process will be executed by the CPU. Now let us look into the waiting time and turnaround time of the process. So for P1, the waiting time is, see, P1 waits until 6 milliseconds to get its turn. So P1 waits until 6 milliseconds. Okay. Whereas, so the waiting time for P1 is 6 milliseconds. For P2, so since P2 has the highest priority, this is the first process which has started its execution. So it did not wait for any time. So the waiting time is 0. Okay. And its completion time is 1 millisecond. Okay. Completion time of P1 is 16 milliseconds. Okay. So it has completed its execution at the 16th millisecond. So it is 16. That is, turnaround time is 16 for P1 and 1 for P2. If you consider process P3, so its waiting time is, see, it has waited until 16th millisecond to get its turn of CPU. Okay, so the waiting time is 16 milliseconds and its completion time is 18 milliseconds. The next P4 has waited until 18 milliseconds to get the CPU and it has completed at 19 milliseconds. So 18 is the waiting time and 19 is the turnaround time of P4. Finally for P5, see, look into P5 here. So for P5 it has waited up to 1 millisecond for getting its turn of CPU and completed at 60 milliseconds. So waiting time is 1 and turnaround time is 6 milliseconds for P5. So the average waiting time is, so 6 plus 16 22, 22 plus 18 40, plus 1 41. So 41 by 5, it is 8.2 milliseconds. Similarly turnaround time, total turnaround time, so 16 plus 1 17, 30 plus 18 35, plus 19 54, plus 6 60. So 60 by 5 it is 12. So 12 milliseconds. So this is how we have to schedule the process if the process have been assigned a priority. Let's look into another case where more than one process have the same priority. So here you have to consider the FCFS schedule. Okay, you have to work out with the combination of priority and FCFS scheduling. Okay, start off with priority scheduling. Then if you encounter any set of process which has the same priority, then you have to consider FCFS scheduling. Now let me explain you the same with this Gantt chart. So initially, so if you look into the set of process, highest priority process is P4, then P2 and P3 has same priority which is 2, and then P1 and P5 has same priority which is 3. Okay, so you have to start off with process P4. So it continues, it completes its execution at 70 millisecond. Then there is a confusion with among P2 and P3 which one to start, because both has the same priority. So in this case you have to follow the FCFS scheduling algorithm, that is first come first served. Whichever process has come into the ready queue first, that process will be served first among these two. Okay, so P2 has come first because the process ID denotes the arrival of the process into the ready queue. Okay, so first you have to execute P2. Okay, so whose burst time is 5, so 7 plus 5 it is 12 milliseconds. Then P3, so it is 8 milliseconds, so 12 plus 8, 20 milliseconds. Then you have to compare P1 and P5 because these process has same priority which is priority number 3. So among these two, P1 has come into the ready queue first. So you have to first complete P1 and then move to the process P5. Okay, so P1 has 4 as the CPU burst time, so 20 plus 4 24. Then P5 which has 3 as the 3 milliseconds as the CPU burst time, so 24 plus 3 it is 27. Okay, so if you calculate the waiting time and turnaround time of process P1, so P1 is here, so it has waited up to 20 milliseconds and completed at 24th millisecond. Okay, so waiting time of P1 is 20 milliseconds and turnaround time is 24 milliseconds. Similarly for process P2, so it has waited up to 7 milliseconds, then completed at 12th millisecond. So waiting time is 7, turnaround time is 12. Then for P3 it is 12 and 20. Then for P4 waiting time is 0 because P4 is the process with the highest priority, so it has started immediately. So waiting time of process P4 is 0 and the turnaround time is 7. Then for the last process P5 it is 24 and 27. So average waiting time is 20 plus 7 27 plus 12 39 plus 24. So I 39 plus 24 59 63. So 63 by 5. Sorry, 20 plus 7 27 plus 12 39 59. Sorry, it is 63 by 5. So I think 12.6. okay, so the answer is 12.6. So if you consider the turnaround time, so total turnaround time is 7 plus 2, 7 plus 7 14 plus 6 22. So it is 90. So 90 by 5 you have 18 milliseconds. Okay, so this is how you have to calculate the you have to execute the process if more than one process has same priority. In this case, two processes has same priority. Sometimes it may be more than two. So again, that there also you have to look into the order in which they have come into the ready queue, and then you have to follow the FCFS among the process having same priority.
In the next video, I am going to explain you how to handle a set of processes having equal priority using round robin scheduling algorithm instead of first come first serve.